Okay, in this lesson we are going to look at scale diagrams or scale models and similar objects and scale models and scale diagrams. And we have all seen probably some scale diagrams or models. So for example, if you look in your science textbook, you may see a scale diagram of a human cell, which is much bigger than an actual cell. Or you may have seen a scale model of something like the Eiffel Tower in Paris, which is much smaller than the Eiffel Tower, so you can put it on your bookshelf at home. First of all, the definition. A scale diagram is a drawing that is either larger or smaller than the actual measurements of an object, but still proportional to the original. So the proportions are kind of the same. It looks similar, but it's just much smaller or larger. How do we determine the scale factor? So actually get a new number for what that scale factor is this. It's a fraction of the diagram measurement over the actual measurement. So something that may be helpful for you is you know that if the diagram is smaller than the actual, then your scale factor will be less than 1 because this numerator is smaller than the denominator. So if it's less than 1, then your diagram is smaller. Okay? Or vice versa, if it's greater than 1, then your diagram, that would mean that your numerator is larger than your denominator, then your diagram is larger than the actual model or diagram. Let's look at a couple of problems in this lesson. First of all is a scale drawing of a builder's plans. So this says a builder plans to construct a house on a rectangular lot as shown in the sketch. So here's the sketch, this is the diagram, and it says draw a scale diagram of the lot using a scale of 1 to 500. So here's the actual measurements. So these are the actual measurements. Okay, all of these measurements in meters. It says that the scale is going to be 1 to 500, so the diagram, in other words, is going to be 500 times smaller than the actual. There's two ways of calculating what the diagram measurements are going to be, so these have to be 500 times smaller than these measurements. One way is to have a scale factor. We know that it's going to be 1 over 500, and if I just divided that on my calculator, that's 0.002. So there's two ways I could find the diagram measurements. I could either multiply all of these by 0.002, so 2 meters times 0.002 is 0.004, and that would be in meters. That's what I would like to be in my diagram. It's 500 times smaller. Another way is to just divide by 500. So you could take any of these and divide it by 500, and you get the same answer. In fact, I can show you that 2 divided by 500 is equivalent to 0.004. So you can either multiply by the scale factor, or if you know it's 500 times smaller, you could divide by 500. It's up to you. I'm just going to divide them all by 500. So 4.5 divided by 500 is 0.009 meters. So these are all the diagram measurements. 40 divided by 500 is 0.08 meters. 9 divided by 40, sorry, should be divided by 500, 0.018. And when you're using the scale factor, it is being converted into the same type of units. So you'll see here that these are getting converted into meters. So it's 0.024 meters. And finally, 15 divided by 500 is 0.03 meters. Now in this particular problem, if I'd like to draw the sketch, it's suggesting that each square is 1 centimeter. If you're using the study guide, you'll see that it is 1 centimeter. If you are just watching this video, obviously this is smaller than 1 centimeter or larger than 1 centimeter, depending on the size of your screen. But if you have my study guide, they're each 1 centimeter. Now what we want to do is convert all of these diagram measurements into centimeters. So in order to do that, you must know that 1 meter equals 100 centimeters. So if I multiply these all by 100, I will get them in centimeters. So this would be 0.4 centimeters. This would be 0.9 centimeters. I'm just timesing them all by 100. this would be 8 centimeters. This would be 1.8 centimeters. This would be 3 centimeters. This would be 2.4 centimeters. So I've converted them all. So if I'm to draw that, I would have as my sketch, the outside would be 8 by 3. So this would be the outside lot. 8 centimeters by 3 centimeters is the outside lot according to the scale diagram. So this is the scale diagram. Next, we know that this distance here is 0.4 roughly from, this is 0.4 centimeters. We know that this distance here is 0.9 centimeters. And we know that the house itself is 2.4 by 1.8 according to our scale diagram. So 2.4 by 1.8 would look roughly like this. 2.4 go to here, and 1.8 would go roughly to here. So our scale diagram, you could also put the measurements on here if you'd like to. This is 1.8 centimeters, this is 2.4 centimeters, and there is our scale diagram according to a scale of 1 to 500. Let's look at one more example. Example 2. If you have the study guides, the measurements will be more accurate according to what I have. If not, you're just going to have to bear with me and trust that these measurements are on a study guide, but your screen will be a different size. It says, Jess works for Mitsubishi. She wants to enlarge the logo she found on the internet so it can be applied to the front of a cap for a baseball tournament. The hat company suggested a scale factor of 5 to 3. So in other words, the diagram is going to be bigger than the actual. So what we're going to do is we're going to multiply this actual by 5 over 3, which is equivalent to about 1.6 continued, so whatever you like to do. So draw a scale diagram of the logo as it will appear on the baseball cap. If you are in my class and have the study guide, you may want to pull out a ruler, and in order to apply the scale, we have to know the measurements that we're going to apply it to. So if you're in my class, you'll notice here that all of these measurements are 1.5 centimeters. These are all 1.5 centimeters, all 1.5 centimeters. All of these distances are 1.5 centimeters. You can measure and confirm that yourself in the study guide. And something that will also be useful is to recognize that the height here, you may want to measure that yourself, is 4 centimeters. So we like to take all those measurements and multiply them by 5/3. So if I multiply 1.5 by 1.6 continued, I get roughly 2.5. So all of these measurements, maybe I'll start on the bottom. So here's 2.5, 2.5, 2.5, and 2.5. So that would kind of be the bottom, because I'm multiplying them all. These reach 2.5 centimeters. Okay, and the height, if we take the middle, the midpoint of this 2.5, it's roughly here. The height being 4 centimeters, if I multiply that by the scale factor, that's roughly 6 2/3. So the height would be, here's 6 2/3, roughly here. Okay, so there we go. And if I use my ruler, and you may want to do this on your own, these are all 2.5 centimeters using the scale factor. I'm multiplying all the 1.5s by the scale factor. So there we go. And we'd also want to meet in the middle here somewhere. Okay. And you can see here that what I've done, as long as you're being consistent and careful, some people struggle with these, consistent and careful, you'll see that what's happening is I've just taken that Mitsubishi sign and used a scale factor of 5/3 on it.